ECA but an ES, so we won't see the retraction of the cryogenic arms because they're not used. But what we will see will be the ignitions of the Vulcan 2 hydrogen cooling gas igniters at around -5 seconds. That's at the base of the thruster of the Vulcan 2.
Let me just stop you because you mentioned the cryo arms. Those are those yellow bars there that are folded that you can see right in the middle of the screen.
Exactly.
Normally they're feeding the upper stage. Tonight they're not because we're not using that version.
Then a gyro ignition of the Vulcan 2 followed by verifications and liftoff with ignition of the SOBs.
Attention pour le décollage. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top, allumage Vulcain. Allumage confirmé. Top, allumage EAP, décollage. Tous les paramètres à bord sont nominaux.
Well, we lost her to the low clouds early, but in a blaze of light. There she is, coming back out of the clouds, roaring off the pad. The DDO says everything is normal, propulsion and trajectory. In a blaze of light and a trail of gold as Ariane 5 reaches into the skies above French Guiana, on her way to deliver ATV-3, which will make her way to the International Space Station next week.
We've lost her through the clouds. So the launch vehicle first clears the pad in a vertical rise. And you can start hearing the noise. And the launch vehicle has just passed Mach 1. It's past the speed of sound. 6 kilometers in altitude, 317 meters per second.
773 tons at liftoff. She's burning 5 tons of fuel every second, 2.5 tons in each booster. Those are the big flames on either side. And the EPC, the core stage, in the center is burning another 300 kilos per second. Ariane, following the program in the onboard computer, which gives all the orders, including stage separation, which we will soon see, because the boosters and the first stage are burning now, and the boosters will burn another maybe 20 seconds and then get the order from the onboard computer.
In all, they will burn for around 2 minutes, and they will deliver 90% of the thrust at liftoff.
Boosters burning their 240 tons in just over 2 minutes. You can see the 3 points of light there, the 2 on either side. If they come back, it looks like we lost her to the clouds again. 2 on either side are the boosters. Luca, on the left, on the upper left of the screen, there's a cursor, and on the bottom left, A and V.
That's right. A, the altitude. We are at 63 kilometers already, 2 minutes and 20 seconds, and we are at 67 kilometers from Earth.
Séparation des EAP.
And the DDO just called out the successful extinction and separation of the boosters. You see what that looks like? There's one on the other side out of camera range. Dropped right on time and on target. Before the boosters are empty, their push diminishes, and this is what the onboard computer senses, a drop in acceleration, and then it separates them. Separation occurs 1 second after the onboard computer has detected this speed loss. Did you mention the altitude and the speed?
Right, so V, the speed, as you can see, 2.24 kilometers per second, not per hour. And if we look at the curve is a projection of where it should be, and the dot is the actual position of the launch vehicle. So as long as the dot remains on the curve, everything is going very well.
So it's real time superimposed on optimal, a real trajectory superimposed on the optimal provision. Okay, we're waiting for the fairing jettison.
So the fairing is a 17 meter by 5. We've had separation of the fairing.
You can see how that happens. There are 2 halves, actually. The other is out of camera range on the other side. Blown away by what? A series of pyrotechnic cords, I think.
That's right. So it's actually a very light structure, although it is 2.4 tons. But it's 17 meters high, 5.4 meters wide. It's carbon fiber sandwich around aluminum honeycomb. And it protects the payload from the dense atmosphere as it goes through. Then once we get out of this dense atmosphere around 100 kilometers up, we don't need the fairing anymore. So we have a vertical separation system, a horizontal separation system, and they break the fairing in 2 at the separation.
We don't need it, it's just dead weight. Why not get rid of it? Back with more of the mission in a moment, but for now, the latest news from Ariane Space. On February 13th, the European Space Agency successfully launched the first Vega vehicle from French Guiana, orbiting 2 scientific satellites and 7 small satellites for European universities. This historic mission now gives Europe a full family of launch vehicles and provides Ariane Space with the world's widest range of commercial launch services.
At the World Space Risk Forum in Dubai in February, Ariane Space reaffirmed its commitment, now 27 years running, to telecom operators in the Mid-East. 3/4 of the satellites here have been launched by Ariane Space.
On February 2nd, Ariane Space and the European Space Agency signed an agreement to launch another part of the vast Galileo constellation in 2014 and 2015 by Ariane 5. Launch of these satellites will complete the deployment of the Galileo fleet. All 26 satellites will be orbited by Soyuz and Ariane from the Guyana Space Center.
The Satellite 2012 conference took place in mid-March in Washington, D.C. Here, Ariane Space confirmed its position as the global reference for the world's top satellite manufacturers and operators. Here, Ariane Space signed 2 new contracts, one for the launch of Jabiru-1 for the Australian operator NewSat, another for Eutelsat 25B SailSat-1 for Eutelsat and its partner in Qatar, SailSat.
There's the mock-up of the ISS, the space station, here in the hall, which is sitting next to the mock-up of the ATV. We'll have more on that in a moment. We've had signal picked up by our first downrange tracking station. That's in a boat in the Atlantic.
We use 5 ground range tracking stations for this flight. We need them to recuperate the launch vehicle data during the flight, which is sum of part verified in real time to see that the flight's going well, and the other is verified after the launch in greater detail to see that everything is also going well.
Film on the launcher campaign now. You'll see the co-el, you saw him earlier, Christian Lardo. The launch campaign started on November 2nd last year in the Launcher Integration Building called the BIL. These operations were overseen by Astrium, who assembles the Ariane 5.
During the integration phase, the main cryogenic stage was erected. It was then assembled with the 2 solid rocket boosters and then the upper stage with storable propellants. The latter is only used with the Ariane 5 ES version of the launcher, which is used for the ATV program. We carried out mechanical integration and functional checks. Electrical and fluid connection were established and an overall check was completed to validate the launcher integration. This phase was completed last December 17 in the Launcher Integration Building when the launcher was handed over to Ariane Space. 2 days later, the launcher was transferred to the final assembly building.
The campaign then continued with a phase which allowed the customer to access the ATV, now integrated atop the launcher, to carry out vital operations inside, like loading the cargo. Then the ATV was encapsulated under the fairing, the upper stage was filled with propellant, and altitude control systems were put in place.
Finally, after completion of final preparation operations at the BAF, the launcher was transferred to the launch zone.
Eight minutes and 12 seconds into flight. Everything is going on well, and we're getting close to the second event, the extinction of the EPC with its separation, and then the EPS stage. So the EPC, 30 meters long, 4.5 meters wide.
Everything okay, he's saying.
And a total mass of 278 tons, with only 14 tons of dry mass, and the rest is all propellant, liquid oxygen and liquid hydrogen. A thrust at liftoff of 136 tons and a flight time of some 8 minutes and more. So we're getting close by.
Which is coming to an end. You'll hear the DDO call out the extinction of this core stage. We're waiting for confirmation of that. And there it is.
There it is. So the EPC stops once separation of the stage, as we can see.
You can see how that happens there. There's 3 commands given in the space of about 12 seconds. The extinction of the lower
Premier
stage,
allumage de l'EPS.
the separation of the lower stage, which you can see, and then
Tous
finally
les paramètres à bord sont
the
nominaux.
ignition of the upper stage. Our speed, as you can see, 7 kilometers per second. Our altitude, coming up to 140 kilometers.
And now the EPS is starting to burn. We'll have 3 burns for the EPS. It's a small stowable propellant stage, and it will give us the 2 burns, the 2 burns necessary for the mission, and a 3rd burn to deorbit it at the end of the mission.
Would you say that's the role of the EPS, the upper stage? Does that sum it up, or is there more?
The EPS is interesting because it's a reignitable. We have to put the ATV on a circular orbit, and this is what we can do with an EPS. But you can only do that if you have a reignitable stage, which is so. So the first burn will take around 8 minutes and 11 seconds.
Les paramètres de propulsion et de pilotage à bord sont normaux. Le vol est calme.
And everything is going well. Then the second burn, after a very long ballistic phase, will give the necessary impulse and speed to make a circular orbit, and after that we'll have the separation of the ATV.
Separation of ATV coming up at about 58,